Check, check.
That's good. Don't get blinded by the light, though.
All right.
Yeah, cool.
Is this good?
Yeah.
My name's Kas Osterbuhr. I am exosphere3d.com. You'll find me everywhere on the internet if you look. And I'm going to show you about my Flight 1549 reconstruction, which is very deeply rooted in geospatial data, although you might not think it at first. The way I'm going to show you that is I'm going to strip away all data and just start from scratch. We can draw a paper map with a pen, and we see that the plane takes off at LaGuardia. It hits a bird or two and lands in the river. So that's very much a crude reconstruction. So we add a little bit of data to that by taking satellite imagery. And in this instance we had half-meter pixel resolution, which is great. Downsample that in some of the larger areas to be able to work with those. And of course a flat image is no fun. So we drape that onto a 3D surface, which is created from digital elevation data. And this adds a perspective and realism to the animation, but it also tells us something pretty cool about the flight path. The aircraft recorded altitude information, which you'll see here. This is altitude versus time. The data from the aircraft is plotted in addition with a ground trace of the altitude of the Earth below the aircraft. And I want to point out the deviation there in radar altitude and pressure altitude, which occurs right where the plane's flying over a high spot in the terrain. So it's a great validation tool for the information that goes into the flight path. Something else that needs to be validated with data from the aircraft is latitude longitude. The lat-long pairs from the flight data recorder in this instance are stair-stepped, so we use raster and vector data at the airport to fine-tune the location of the flight path. Radar facilities on the ground record the position of all the aircraft in the vicinity in polar coordinates. To get that onto the map, we use the geospatial framework to project that onto the ellipsoidal Earth. It's a great way to visualize what's going on. Airspace polygons tell us about the responsibilities and duties of the air traffic controller and adds in the understanding of what's happening as well. An interesting aspect of this accident was the birds, and at the far right here you see Flight 1549 tracking to the north, and the small boxes are actually radar returns from the flock of birds. So it's neat to map this all out on a map and see where the birds started, where they're headed, and get that piece of data. To augment the realism of the animation, we want to put trees and buildings and so forth, so that can be done with canopy height, ground classification, and so forth. You see here a zoomed in area of Central Park. This animation has 7 million total trees distributed, and you see the building footprints. I was very lucky in this case that there was a commercially available LiDAR data set which had polygons and textures for all the buildings in the area. So I brought that into 3D, and it really made a big difference in the overall animation. Vector data for street locations and other features are important in understanding where witnesses are standing and what they see in their environment, so that is a critical component. And as well, there was actually live video of the plane splashing into the river, and from the location of where we know the camera is, you see here the plane is just touching down on the river. In the far distance you see the buildings. We look at this from a top-down view, and we can plot out the azimuths from those keyframes and add to the information from the flight path where the plane touches down. And that pretty much does it for the reconstruction aspect. I pulled off one witness statement, one of the passengers. Oh, I've skipped NextRad. In this accident, NextRad data wasn't important, but again, that's something that is geospatial. It has a point, range azimuth, and we can plot it right in with all the other data. This is a passenger statement from one of the many people on board. I think that's the understatement of the year 2009. And they were very lucky. So my application for GIS is, I'm sure, completely different than what you guys use it for, but hopefully this can give you a little bit of perspective of different uses. And thanks for your time.